Okay, hello everybody, what's going on? This is Mohammed, welcome to another video. In this video, I'm going to teach you how to solve for this indefinite integral of the square root of 4 minus exponential to the power minus x dx. Okay, so to solve for this integral, first of all, let's get rid of the square root, okay? So we can do a simple u substitution here. So we can let the whole thing equals to u. So that's what we're gonna do here, okay? So let u equals the square root of 4 minus e to power minus x, and then I'm going to square both sides, so that's going to give me u squared equals 4 minus e to power minus x, and then I will move the e to power minus x to the other side, and that would give me 4 minus u squared. And then we need to express x in terms of u, so we need to take the natural logarithm of both sides, so that would give us minus x equals the natural logarithm of 4 minus u squared, and then I will differentiate both sides, so minus dx is going to be equal to minus twice u divided by 4 minus u squared du, and then to calculate for I can take the negative from both sides, so dx is going to be equal to twice u over 4 minus u squared du, that's dx. So if we take this and substitute it back instead of dx, and we have u instead of the square root, so that would give us 2u squared divided by 4 minus u squared du. So that would make it a lot easier. So our integral now is equal to the integral of 2u squared over 4 minus u squared du. Now, one way to think about this is to try to make the numerator look like the denominator. So to do this, we can take the 2 outside, okay? And we have 4 minus u squared in the denominator. We have u squared in the numerator. So first of all, we need to make the u squared negative. So if we add a negative sign here, we have to add a negative sign there. And then we need to add up 4. And then we need to subtract 4, of course, so that the whole quantity doesn't change in value, du, okay? And then this is going to be equal to minus twice. Of course, the first integral is going to give us 1. So basically, the integral for that is u. And then minus 2 multiplied by minus 4, that's going to give us 8. So that would give us the second integral in the numerator. We're going to have, in the numerator, we're going to have 8 divided by 4 minus u squared du in the denominator. So this second integral can be basically solved right away. We have a formula for that using the inverse tangent hyperbolic. Okay, so we can do that actually. So this can be rewritten like this. Okay, the 4 can be written as 2 squared, okay, and then this is going to be equal to minus twice u plus, of course, 8 divided by 2, which is 4, the tangent hyperbolic inverse of u divided by 2 plus c, okay? And then we can substitute back the value of u, and we're done, actually. So that would give us minus twice the square root of 4 minus e to power minus x plus 4 tangent hyperbolic inverse of course, half multiplied by the square root that we have originally, which is 4 minus e to power minus x, and plus c, the constant c, and that's basically the final answer for this problem, okay, which I will, okay, but I mean, some people, they're not fine with using the hyperbolic inverse, the tangent hyperbolic inverse. Okay, so we're gonna redo the or resolve, okay, the second part of the integral using partial fractions, actually. So I will assume that the second integral here, and I will mark it in red, the second integral here, I will call it I2, and I will find it separately, okay? So let's do that. Okay, so I2 is gonna be equal to the integral of 8 divided by 4 minus u squared du, which can be basically written as between two parentheses, two fractions, okay, a divided by 2 minus u plus another fraction where of b divided by 2 plus u, and let's square the parentheses and, I'm sorry, du, okay? Du. Okay, good. Now we want to calculate for A and B. A can be obtained right away by removing 2 minus u from the original expression, which is this expression here. So in the denominator we have 4 minus u squared. So if we remove 2 minus u, we're going to be left out with 8 over 2 plus u, and we need to evaluate this over the root of 2 minus u. So the root of this parameter here is 2, so u equals 2. That would give us 8 divided by 2 plus 2, which is 4, and that would give us 2, of course. Okay, so that's basically the first value here. Okay, the second value unknown, which is b, is equal. Again, we can go back to the original expression, 8 divided by 4 minus u squared, and remove 2 plus u from there. We're going to get 2a divided by 2 minus u, and we need to evaluate that at the root of the second expression, which is basically minus 2. So u equals minus 2, so that would give us a divided by 2 minus 2, which is basically 4, and that would give us also as well 2. Okay, so now we have calculated for a and b. Now we need to go back and substitute that in the integral I2, so that would give us a, which is 2 divided by 2 minus u, plus another integral. The second integral is basically also 2 plus over 2 plus u, and let's put that between parentheses, du. And then, of course, we know that the integration of the first part here, we need to have the derivative in the numerator. So the derivative of the denominator is minus 1. So we need to multiply by minus 1 and divide by minus 1. So that would give us minus the natural logarithm of course, 2 minus u. Okay. And then the second part, we have the derivative already. So that would give us, of course, there's a 2 here that we forgot actually. Don't forget the 2 in the, so minus 2 here, and plus 2 here, the natural logarithm of the absolute value of the denominator, which is 2 plus u, okay, plus c, of course. Well, here we have two natural logarithms that are subtracted from each other. So basically, we can rewrite that. We can take the 2 as a common factor, and that's going to give us the natural logarithm of the positive part, the positive term, which is 2 plus u divided by the negative term, which is 2 minus u, and then we close, plus c. And if we go ahead and we can go ahead now and substitute the value of u there, which is basically the square root of 4. We can do that, and we can leave it as is, but let's do it. Okay, so the whole thing is going to be what? Is going to be 2 plus the square root of 4 minus e to power minus x divided by 2 minus the square root of 4 minus e to power minus x. And let's make this shorter and close the absolute value plus c, of course. Now, if we go back and add that to the original term there, we're going to get exactly the same result. Now, if we compare this result, okay, with the result that we got here in the yellow box, they are basically exactly the same. Why? Because the tangent hyperbolic, and I will write that down here, the tangent hyperbolic inverse of x is nothing but half the natural logarithm of the natural logarithm of, I'm sorry, of 1 plus x divided by 1 minus x. Okay, that's the relationship between the natural logarithm and the inverse tangent hyperbolic. Okay, so that's it. That's the final answer here in the box. That's the final answer, which can be rewritten using the natural logarithm using the formula down here, or we can go and use the partial fractions to do the job. Okay, thank you guys for watching. If you like this video, hit like. If this is your first time here and you want to know more about brain teasers, riddles, logic puzzles, viral math problems, and all types of mathematics related problems, then start now by subscribing to the channel and clicking the bell so you don't miss anything in the future. Thank you again for watching and see you in another video.